Hello, SAT prep students. Today I'm going to talk to you about interpreting linear functions. This will be a part one of a two-part series of lessons. So let's start with some stuff that you probably already know. When setting up linear equations for word problems, consider which linear form matches the information you are given. One of the earliest linear forms you learned was the slope-intercept form, which looks like y equals mx plus b, where the m represented your slope, which we always thought of as rise over run. But what you really need to understand, it's a rate of change between the x and y variables, okay? In fact, when we look at rise, we talk about the change in the y's over the change in the x, which, by the way, that little triangle means change, okay? All right. And the y-intercept is your b value. This is the value. Oops, that looks terrible. Mostly because I'm making this video at home and I had a cat jump on the table and shake my computer. Anyway, the y-intercept is the value that occurs when x equals 0. Okay, and you'll see that more in context in a little bit. All right, so let's take a look at this example. It says d equals negative 200t plus 9,000. So first of all, let's think of d as like your y and your t is like your x, okay? Just so you can kind of have this in perspective of slope-intercept form. It says Harry took out a loan from a bank. Each month he pays a fixed amount of money back to the bank. The equation above shows the remaining amount of the loan D measured in dollars after T months. Okay, so how much does Harry pay back to the bank each month in dollars? Okay, so when we're looking at that, when it says how much does Harry pay back to the bank each month, this is dollars per month. Notice that this involves both variables, so this is a rate of change. And so what we're looking at is the slope. So when they're asking how much money does Harry pay back each month, we're asked what is the slope of this line? Well, the slope, remember y equals mx plus b, we said that m represented the slope. In this case, that's going to be the negative 200. To interpret this problem, it means that Harry pays back $200 each month. That's why we're expressing this with a negative quantity. Okay, he's paying this money back. He's not getting this money, he's giving it up. All right. Let's discuss this one together. We have W equals 32 minus 0.05 n. Let's read the scenario and then see if we can reinterpret that as a slope-intercept form. It says Andre, I'm not sure how to pronounce his name, Bob, has a glass tank. First, he wants to put some marbles in it, all of the same volume. Then he wants to fill the tank with water until it is completely full. The equation above describes the volume of the water W measured in liters that Andrei, or whatever his name is, should use when they are in marbles. What is the volume of the glass tank in liters? All right, well, the first thing before we actually go into this is let's figure out the slope of the situation. So we're looking at the variables that contain volume of water, W, and we are talking about measured in, that's just the units on it. We're also talking about in marbles. So we're looking at the volume as it's related to the number of marbles, okay? So when we look at this, let's think of the n as our x variable and w is like our y. Normally we would write this in y equals mx plus b form. So I'm going to transform that. So this negative 0.05 is with the variable, so I'm going to rewrite it as such, plus 32. So negative 0.05x, what that is saying is that whenever we have that value multiplied to the number of marbles, the volume of this particular tank decreases by, it looks like 0.05 liters. So negative 0.05, the volume in the tank decreases by 0.05 liters. And why do I know it's liters? Because they told us right here. So decreases by 0.05 liters for each marble put into the tank. And the y-intercept, well, that would be the 32. An empty tank, meaning there are 0 marbles, an empty tank holds 32 liters. Okay? All right. In class, you're going to get to do a 4 corners activity. So what I do not want to do is go over these on this video or put them on the key, because I want you all to do these in the classroom. So just look through them and see what you can figure out. Okay. Here are a couple 4 corners. I will go ahead and try these whiteboard ones though. A young sumo wrestler decides to go on a special diet to gain weight rapidly. Once on the diet, he gains weight at a constant rate. The equation shown above gives the sumo wrestler's weight W, measured in kilograms, after T months on the special diet. What was the sumo wrestler's weight in kilograms before he started his special diet? So before he began his diet means no months have passed, which means T equals 0. In this case, our T is like our X and our W is like our Y. So what was the sumo wrestler's weight? Well, that would be like the y-intercept. So it would be 80 kilograms. How about this one? A cruise ship, a big cruise ship drops anchor at the Caribbean island of Antigua. The heavy anchor drops the water at a constant rate. The equation shown above gives the anchor's elevation E, measured in meters, relative to the water's surface after T seconds. How many meters does the anchor drop every 5 seconds? Okay, so T represents seconds, so negative 2.4 is going to be a drop of 2.4, and what are our units? Meters. Every second. So this one asks, what is it every 5 seconds? So we just have to take negative 2.4 times 5, and it would have to drop 12 meters. I'm trying to decide if we need to put in negative 12 here, or since it's asking how many does it drop every 5 seconds, I could just say 12 since they're asking about, well, it's dropping. So 12 is what I'm going to go with there. All right, we have a few SAT problems here. I'm going to model through those. A helicopter initially hovering 40 feet above the ground begins to gain altitude at a rate of 21 feet per second. Which of the following functions represents the helicopter's altitude above the ground, y, in feet, t seconds after the helicopter begins to gain altitude? Okay, so we have to think about the altitude, y, as a function of how fast we're going. So like when we start at 40 feet and we're gaining an altitude at a rate of 21 feet per second. So 21 feet per second, that sounds like a slope because it involves a rate of change. So it's going to be 21 t. Okay, and it says we're gaining in altitude. We were initially hovering 40 feet, so that means 40 feet when 0 seconds pass. So plus 40 is like our y-intercept. So our correct answer is going to have to be B. Even though they wrote the y-intercept first, that's okay. That can happen. On the next one, we have h equals 1.88L plus 32.01. It says the formula above can be used to approximate the height h in inches of an adult male based on the length L in inches of his femur. What is the meaning of the 1.88 in this context? So 1.88, it is acting as a slope. So let's see, our h was height, so 1.88 inches in height for each inch of femur length. So let's see how we can think about that from these choices. The approximate femur length in inches for a man with a height of 32.01, no. The approximate increase in a man's femur length in inches for each increase of 32.01 inches in his height, no. The approximate increase in a man's femur length in inches for each 1 inch increase in his height, no. The approximate increase of a man's height in inches for each 1 inch increase in his femur length, yes. By the way, it had to be that last one because when we talk about rate of change, remember, think of this h as your y, your L as your x. Rate of change is always thought of as the change in y over the change in x. Your y is your height of the man, and the x is going to be the length of the femur. Okay, so it's going to be the height change of the man for every inch of femur length. Okay. The next one, in air, the speed of sound s in meters per second is a linear function of the temperature T, air temperature T, in degrees Celsius, and is given by the function s of t. So this is just like saying y equals 0.6x plus 331, 0.4. Which of the following statements is the best interpretation of the number 331.4 in this context? Okay, so T is temperature and S is going to be the speed of sound, so the speed. So this would be the speed at 0 degrees Celsius, okay? And the reason for that is because the x would be 0. In this case, the x is the T, which would be the air temperature, and it'd have to be equal to 0. So the speed of sound in meters at 0 degrees Celsius, okay? All right, so now that you've had a chance to look at some examples here, you're going to get to try some problems out on Delta Math that will practice interpreting linear functions. Please try to finish this before the end of the period. If you're at home because of quarantine or whatever, it will be due by next class, but try to finish it as soon as possible.